Hello everyone and welcome to Handmade Hero, the show where we code a complete game, live on stream. We did what we needed to do yesterday to put multiple render layer compositing into the software renderer, but we didn't have a chance to optimize it, so when you run it right now, it's kind of unbearably slow. For example, if I load it up here, and run it. This is the speed we're looking at normally, which is around 30 frames a second here on the software renderer. And then when I hop on the stairs and try to go upwards, you can see it chug down to like almost, I don't know what that is. It's 100 milliseconds a frame, so something ridiculous like 6 frames a second or something like that. I don't know, really, or 10 frames a second rather. Not great, not great. And we know why that is. It's pretty straightforward actually, because we didn't do an optimized version of the blit. We just did a reference one to make sure that everything was working properly, and that's great, but we need to replace it now with one that actually does a more optimized version. So when I look at blend render target here, you can see here is the super slow version, right? And that is because it's it's not at all using any SSE or anything like that. It's just doing the standard slow way. So what we need to do here is take effectively this code that we were using for filling rectangles and convert it to do blending of these two rectangles, right? So that's what we're trying to do here. So I'm going to go ahead and see how hard it is to make that happen. You can see here most of the stuff, start and clip masks and all that stuff is going to be basically the same, right? There's really not a whole lot to it. I don't think as far as this is concerned. I think this is all going to be pretty basic. Yeah. Nothing in here really needs to change. This is just sort of prepping this. In fact, I wonder if we could at some point make this some shared code. I feel like we could have shared some of this, but anyway. So let's see. So in here where we're actually taking a look at the row pointers, this should be essentially the same as it was before. And so when we've got sort of the row and row advance here, really all we need to do is take the same queue. It's going to be exactly this same stuff that we've got here, so there really isn't anything special about it, right? You can see it's the exact same code that was getting operated there. The only difference is now we need 2 of them. And so we've got a dest row advance and a source row advance as well, one for each, but other than that, we're good to go. So then we come into this code, and you can see that we're just going to do pretty much exactly the same kind of a loop. The only difference is here, instead of just 1 pixel, now we've got a dest pixel and a source pixel. Again, this is exactly analogous to what we were doing before. And then we're going to go through and we got to port all this code where we're going through and doing the operation. But then at the end, really all we need to do is make sure that we update everywhere we were updating only one thing before. We have to update both things, but that's it. Oops. So once we've got that, there really isn't a lot more to it other than going through and changing it so we're actually going to do the right pixel ops now. So we don't have this concept of a color that's being modulated anymore. We just have an alpha. So we've got basically an alpha 4x. We don't have any of the other stuff there that we have to deal with. So really what we need to do here is sort of do, when we're doing our load destination, and you can kind of see how we were doing that here, we just need to now load both the destination and the source, right? So instead of having a constant color that we're using, we need to have both. So we sort of got an original dest and an original source, and those are just, getting the dest pixel and the source pixel out. When we load the destination and are going to operate in that, we want to be able to do a load destination and a load source. So we want to do both of these now, right? And so if you take a look at what happens here, all of this stuff can stay exactly the same. And so this just needs to be modified so that instead of a dest, it's source everywhere. So it basically just produces a source version doing the exact same load op that we were doing before, and that's it, right? Now, when we do our modulate by incoming color here, we're not actually going to be... I think this was a bogus comment. This is just a sign... well, I guess it's not. We were just using the texel as a way of storing that because texel kind of got, was all in there. So this right here, where we're sort of doing the... well, actually, no, I don't really, I guess, to be honest, I don't really know. We're clamping this, but we shouldn't actually have to clamp. I mean, I guess we could clamp if we wanted to clamp, but yeah, since it's constant, I don't even know. This code is super crappy. We should probably just cut that out of our other code because doing a min-max PS on a constant value makes no sense at all. So I don't even know why we're doing this. This is just dumb. So I'm going to go ahead and get rid of all of that. We don't need any of that. All right. So in this case, we need to be able to square our color values. Again, we have to do that for both of them here. So I'm just going to go ahead and change it so that we do both the source and the dest, so that we go, we basically do the gamma step, undo the gamma correct. Then we got to do our blend. And in this case, our inv texel A is actually a constant here, right? So if we want to, we could actually pull this out so that when we kind of have the inv texel A and the texel A, we can do that, that operation in a much more efficient way. So I'm going to go ahead and pull that out here because we don't need to compute that every time. So we've got inv alpha 4x, and that's just going to be whatever alpha 4x was in this case, right? And the same thing is true here. I guess I should look to see where we load up where we do the alpha blending. I'm interested to see here when we actually do the blend. So we do the mul, and then we go. We do the reverse reciprocal square root to get back into brightness space. But I'm concerned because I'm just not sure whether the alpha values are what space we were expecting them in. Because if we look at this code here, right, I feel like this code is all assuming, yeah, and that looks very clearly the case to me. This is all going to be in basically 0 to 65536 space, right? 65535. It's going to be 255 squared, right? And so when we do our destination blending here, and we're going to do our add with our muls and all that, our texel stuff should not be in 255 space, right? It should be inverse space. So I feel like this doesn't need to happen now, because that was if we had loaded it and it was in 255 space. It's not. So we should be able to just do our sub PS where we just subtract 1 minus alpha. We could even do this more directly and just say, it's that. So it's clearer. So we have alpha and inverse alpha, and I think those want to be 0 to 1 because we're using them as a straight up blend. So then when we do our destination blend, we would now, since we're doing a real blend, not a pre-multiplied blend, we're doing a full blend, we have to expand our mul out to basically account for that. You know what I'm saying? There we go. So we have to do a mul on both sides, and in the case of the second side, we're just doing our alpha 4x. Oops. And then here we just have our inv alpha 4x. And we're blending the dest, and we're going to blend the source. So I don't need this texel nonsense anymore. Okay, so now we have our blended values. Those, in theory, should flow through the pipeline correctly, so I don't think we'll have to do anything really... I don't think there's anything more complicated that we need to do there. I'll go ahead and... I don't know why we've still got these blocks in here. Maybe we were testing them out. I'm not entirely certain. But anyway, so if we take a look at what's going on here, I think that's roughly all. I just want to make sure I have the dest and source in the right order there with how we defined the alpha. Yeah, it's 1 minus alpha times dest. So I think that's basically the routine we're looking at. It's not super complicated. And like most of the work is just shared and is done the same way in both things, right? So now we can sort of see what happens if we actually run it. You know, maybe all hell breaks loose, or maybe it's fine. Okay, so it looks like that's just fine, actually. So it looks like that's actually great, and we don't take too much of a hit there. I mean, it is definitely slower, but it's not that much slower. It's still, you know, roughly about the same frame rate. So that's all good. So yay! All right, we've got our, you know, I'm not going to say particularly well optimized, but you know, optimized enough. So optimized enough to not be a problem. So now what we have to do is this to do right here, right? And the problem with this guy is that it sets the alpha value to 1. And we don't want the alpha value to be set to 1. And furthermore, I think we, you know, for clears, I think we want to be a little bit more explicit about how we're clearing these buffers. I think we can write a much faster routine, right? Because for these clears in particular, we're not using we know we're not doing any operations. We're just romping a value in there, right? So in theory, you know, we should be able to take something like this blend render target routine and make a clear routine that's much better, right? That doesn't take as much time to do the actual clear, and that doesn't have to have the alpha weirdness to it, right? So we should be able to do something more, you know, like this, where we just say, well, okay, we know we've just got a dest in this case, you know, no source. And, you know, we know we don't have to load anything. We know we don't have to do any of this stuff, right? So all we really need to do in this case is set these values. So really we're just talking about, you know, up here, we would just say, you know, color R, color G, color B. And since those are all going to be constant, we could do that to begin. Like we could do that initially, right? So this really, really all of this stuff falls away, and we can just pre-make essentially this thing right up here. And once we do that, then all we really have to do is say, well, we don't need to load the original dest. We don't need to load really anything. So all we have to do in this case is just write out the dest pixel. I guess, well, if we want to support fractional clears, I guess we do have to load the dest, right? Because if we were trying to, if we had a clip rect that was down the middle of one of our 4 wide pixel things, that could be a problem, right? So I suppose in that sense we do want to leave original dest as being loaded. So we basically have, you know, the original dest pixel, and then we want to do our masked out where we've got our out value that gets combined with the right mask to get the original dest in there, and then it writes it out. But really, that's the entirety of the loop. You know, this is what we're talking about here, and so you can kind of see in this case it's much nicer, right? it's a much nicer thing. And I'm going to get rid of our Ayaka there because we don't really care about that. So yeah, that's what I'm talking about for a clear. It seems plenty sane to do that, and you can see how simple the code would be if we do it that way. So coming back up here, I don't really know that we need any of this stuff probably. We'll see which of it we actually need. In fact, I'll just go ahead and do this for now. To see which ones we need, but in terms of preparing the buffer, all we really need to do to prepare the buffer is, exactly the things we were previously doing here, we can now do. It's just instead of loading these colors up here, instead we can just instead we can just make these guys come from our color values. Well, actually, I guess I'll do that here. All right. So yeah, so if I do a color R equals mmset1ps, and I use whatever the color R is, and I just get these loaded up in here. Basically, all I'm doing is I'm just making a baked value that I can use to romp values in. Let's take a look at clear rect, and we don't need this, and we need that. Okay, that's got to go away. All right, and so now, in theory, we could, instead of doing this, we could say instead of draw a rectangle, we will do clear. What did I call it? Clear rectangle? Let's call it clear rectangle. And it just takes a rect, a dest target. Oh, we don't even need the. Oh yeah, we do. We need the dest target. So it just needs a rect, a dest target, and that's it. So yeah, if we're gonna do that, the rectangle in this case is like this right here, and the color we can now use directly. So I think it's roughly that. I don't think there's a lot more to it. So let's see how that does now. And so that's clearing to black, which I'll be honest, I'm not sure. That doesn't seem right. So we must have a bug in our code there. But at least now you can see we're clearing the alpha value. Oh, well, I guess no, we weren't. So why, I don't know why that's clearing to black. We'll have to take a look at what's actually going on with the colors here. So this actually gets assembled. We don't really need to assemble this in SSE for any particular reason either. So that's kind of a little bit weird, I suppose. But, you know. In fact, yeah, I have no idea why we would do that. That's a little bit odd. Because really all we need is one of these guys. You know, we could just take the pack, you know, do a standard pack color operation on it and then put it in there. Yeah, well, anyway. So I'm going to step in here just so I can take a look at what's actually going on there and see what I think in terms of debugging it, and then we'll go from there. So let's see. We want handmade render, and we want in here somewhere to, there's clear rectangle. All right, so what's the color value? Oh, I also want to turn off optimizations, because I want to actually be able to look at my code. Novel concept, I know. So we come in here to my little lovely routine. And oh god. Okay, great. One more thing we need to do is turn off the threads, because of course Visual Studio doesn't make it easy to just step through the individual thread. So let's see where we actually take our make queues for the high priority queues. I think, let's see here, high priority queue. So can I just say 0 here? We should have a an easy way to turn off threading in the renderer. So, all right. Here's our settings nonsense. Let's take a look at what we're actually asked to do. So here's the clear call. The clear call is actually setting the alpha value to 1. And so that's actually not what we would have wanted. And 15, 15, 15 is the actual, or is the actual color values that we're working with there, 0.15. And so let's take a look at what we actually created here as what we wanted to make. So, yeah, that looks unconvincing, to say the least, right? Because, let's see how we went wrong there. Because, you know, we get color R, that's 0.15, 0.15, 0.15, and so on. We then do a mul. Yeah. It's always the like spaces that you're in when you forget. So these are not multiplied by 255. So basically, you know, this guy needs to still be here, and you need to do a mul to get it up to the right range, right? Of course, I could also just do this, I suppose. There we go. And I think that's about it. Let me look at how alpha... So alpha gets packed in directly as well. So I think that is more correct. However, we still... And man, this is so slow. Running in debug mode with no threads. So that's always fine. But that still looks like it's not clearing to the correct color, right? It's not clearing to gray, which is what it should have been clearing to. So we do our set1ps from the 255 elevated colors. We then do the mul. So let's take a look. So our SG. So these are those look like more correct values though. So that seems fine, although they are very dark. So I do wonder, linear 0 to 1 brightness space to sRGB 0 to 255. Of course, those comments are wrong because they're not actually in 0 to 1 brightness space. Should probably eliminate those, because those exist down below and are incorrect. So reciprocal square root, this is going to provide 1 over the square root of the value, right? So, you know, let's see here. I don't really know, I wish I could remember when we had done this originally. I don't really remember why we phrased it that way. Let's see here. There we go. J318. So, we have a value, x, and we want to produce, right, square root of x. But we only have reciprocal square root of x, so we can produce 1 over root x, right? And we want to do an operation to this that will, eventually produce just root x, right? If that makes sense. So it would seem that you would want to do an inversion there. So I'm not sure. We are currently multiplying by the original x. Oh, okay. So that's actually a neat trick. So I guess what we did, and I guess maybe I outsmarted myself here. We basically said, like, can we multiply this by something that will give us this, right? So we said, what times 1 over root x equals root x? And it's like, well, okay, if I have a over root x equals root x, then I multiply both of these together, right, to cancel. I multiply both sides by root x to solve for a, and I just get x, right? So it turns out if I multiply by the reciprocal square root, I get the right term. So that actually looks correct to me. And then when we do our conversions, off we go, right? So it feels like that color value is being interpreted correctly now, yet at the same time, it seems like it's awfully dark compared to what's happening in the other paths. So I guess, and I don't know, but when we do a GL clear, let's see here. Here it is. So when we do a GL clear color here, I don't actually know if GL clear will obey the sRGB factors or not. That's kind of the unfortunate part of it. So, I don't know which is the correct way to I don't know what OpenGL is actually going to do with an sRGB frame buffer when we ask it to clear. Is it going to clear to those values natively, or is it going to clear to those values sRGB adjusted? And of course, it's probably pretty hard to tell, but let's find out. So let's see, clear color. Let's see. When GL frame buffer sRGB extends enable the okay. So basically, if we want to be compliant, we would have to with how the clear is working in the other case. We actually can't. We don't want to do any of this correction, actually. So we just want to treat the values directly. All right. So we're a little better now, but that's still not. That doesn't look like the same color to me. Oh, I'm an idiot. If they are in linear space, then when they get packed into the buffer, that is what should be happening, because if they're in linear space coming in, they then have to be adjusted to pack into the sRGB frame buffer, which will get loaded out later. So the comment still stands, but this operation is correct, I believe. So I still don't quite know why we're getting that effect. I do also want to, before we go any further, want to see why when we do the clear, when we set the clear color. Let me see here, render group, clear, oops. I would like to know why the clear color, when we set it, and I'm assuming that's getting set in here. I don't know why the background color was getting set with an alpha value of 1. That doesn't make a whole lot of sense to me, but, you know, I guess it was. So yeah, in theory, we now have everything correct except for why that color value isn't matching the OpenGL side of things, and so we'll have to take a look at why that's going on. But first, let me go back to here and, oops, re-enable our threading. There we go. So let's go up here. So that's still those, I don't know why those alpha values there are actually I do. I take it back. So we do have one more bug. We've got the color bug, which is that we got to go find out why our color doesn't line up. But we have one more bug as well, which is that in our blend render target routine, now that we know that the clear, or at least now that we're trying to make sure that the clear operates properly, it occurs to me that this actually does not use the source alpha at all in the blend. And it needs to, otherwise you'll never get any of the matte effect, right? We need to look to see if there's anything in the source first. So it actually is going to multiply the alpha value here. In other words, this source color.a, you know, this is sort of the global alpha, right? But the pixel alpha is the alpha value times whatever the source color's alpha value was. So we actually do need to do that. And that's actually the correct thing, because otherwise we're not going to get the transparency, the correct transparency from our source. I'm not sure why I spaced on that, but I did. So here, where we can see doing the alpha inverse alpha, that means the inverse alpha and alpha actually can't be stored, if that makes sense. We do actually have to do the multiply, right? So let me go ahead and grab those in here. So right before we do our alpha blend, in this case, we've got our alpha 4x. It's just going to be a mul, and I'll call this pixel alpha. And we'll just use that pixel. Oops. So that pixel alpha that we load is going to have to be the multiplication of our original alpha 4x and whatever we loaded as our source alpha, right? And the source alpha, when we load it, is going to be in 0 to 255 space. So we also have to make sure that we get that subtraction happening, right? So when we load it here, we have to do an mmul ps of imv255 to make sure that the alpha value is in the range of 0 to 1. Once it is, then we're fine, right? Because we can do our 1 minus, although I guess I can't, it's just called 1. Of course, I didn't add a 4x into that. No one knows why. I just didn't. So that's actually the correct thing to do there. And so now if I did that properly, when we actually do the composite step on top, we should get it showing through in the places where it's supposed to show through, right? At least that's the hope. Yeah, so now that's actually working the way it's supposed to work, and not having those weird solids there. So now I think we actually are down to just the bug of having the incorrect value on the color. So let's take a look briefly back at the place where in world mode where we were actually specifying not the color, but those blocks there where we're rendering the traversables. I guess that's an entity. Here we go. So I basically changed the size of those so that it was like there were those weird little slats. So if I put that back to the previous size, of course we do have the problem of we don't edge them with anything at the moment, which makes it really hard for them to see. Also, have you noticed when we're in this render mode, by the way, we don't get the bending. I'm wondering, did we not do the correct... sorry to jump around here, but did we not do the correct bending for render entry bitmap? I'm wondering about that. So here it is, right? And it's like entry P, and it's got the x-axis and the y-axis, but it doesn't seem to actually bend the way that you would expect it to. You know what I mean? Was there something else that was being done here that would have made that happen? Primo color. Like, is our draw rectangle quickly doing something that it shouldn't be doing as far as the x-axis and y-axis are concerned? I'm not sure. Because, like, just take a look at the difference. Do you see the bending that's happening there? Right? And now if I switch to the software renderer, it doesn't bend. So, like, that equation is wrong. So something about how we're positioning it, it might be just the minimum P positioning that's wrong. I'm not 100% certain, but we do also have a bug in there that's not a bug that we introduced with what we're doing here or anything like that. But that does seem to be a problem. And so I'm not sure what this stuff is doing here. I also don't know why we have a value called NZ scale that nobody uses. Like, literally nobody touches that value. Let's trim some of this out here. Goodbye. And what's NX axis? Inverse x length squared. So we've got some... And we got some other things here, but I don't know that they actually do anything either. Do they? So it looks like we've got some errors in how the texel lookup works when we do bending here. I'm not sure when we want to go fix that, but I'm going to put a note in here. But it sure seems like there's a bug in there Yeah, I mean, you can see what that's doing, right? It's not actually producing the correct lateral movement, even though the vertical movement actually looks, I mean, not the vertical movement, but the vertical shear actually looks somewhat okay, but the other part doesn't, right? Yeah, so that's interesting to see why that's happening. There's also some really weird stuff with our sort groups at the moment. Why are we getting all of those sort groups? That's very strange. Oops. I guess that could be because it doesn't know what... Yeah, I'm not sure. Basically, I think we've got a lot of debugging to do, if that makes sense. It's never really all that fun to have two different renderers, I suppose, but that's just the way it goes. I wish we could only have the software renderer, but, you know, times being what they are, you can't. Yes, I know you don't recognize that because the OpenGL renderer doesn't have support for the compositor. But anyway. All right, let's take these in order, though. Since we have too many bugs, we got to look at them one at a time. So if I take a look at what's happening here with the color, I feel like, you know, most of our other color stuff seems to be happening properly. We don't seem to have a lot of other color problems. If I switch between these two, the colors look pretty much correct for the most part, right? Although, why is that pink? That is purely bizarre. So I think I'm just going to start with that one, and then we'll look at some of the other bugs tomorrow, because we've got a bunch of them now. So in push, let's see, no, not in push, in render, handmade render, in clear rectangle, it does look like we're doing the operations that I would expect to be correct, if that makes sense. But I'm not getting the results that I would expect to get. And so I'm not sure exactly what's going on there. I think, so when we do our convert PS EPI 32, right, we're expecting the values to be in the range of 0 to 255. Right, obviously. So I'm not 100% sure, though, when we do our shifting left. So I think the problem here is just, again, the cleverness. The problem is these values actually need to be in the 255 squared range, right? So although we don't want to actually square the values because they're in linear space, they do need to be in the correct actual range. And so what we were doing in our previous routine, and I think this is probably the only bug now that I think about it. What we were doing in our routine before is, you know, we had to square the values, and the values were 255 the values were 0 to 255. When we square those, we get 65534 or whatever as the maximum value. So given that fact, we had baked in a reduction by 255 into the shift, right? You can see it here. The way that we were sort of doing our shift left, We're shifting the values down to put them into the right place, if that makes sense. Now, why we would do it this way exactly, I'm not sure. And it kind of looks a little bit janky. So when we do this convert EPI, I'm going to look at the other. I'm going to look at the other render code as well. Let me just look at what we're doing here. So yeah, so there's the squaring, right? So now it's 65536, and then we do the square root, and I think this should be that, right? So that goes down the sRGB, and then when we're done and we do the conversion, I would have thought, I don't understand why these ors don't require a mask. So it's basically saying, well, blue is in the right position because it's centered, right? R has to go up 16. So it's like it thinks these are 0 to 255, but... And I guess the R squirt does that. Okay. So I'm relatively happy with this now. I think that's all correct. So I think all we really had to do was put them in the 65534 space to begin with. Then everything else works properly, if that makes sense. So I think that's correct. Let's take a look at how close we are at the moment. We'll be a little bit off because we're squaring, not doing actual sRGB. So we're pretty good there, although why... I'd also like to know why we suddenly get pink when I switch back to this one. I suppose... yeah, because that doesn't really make a whole lot of sense why we would get pink when we switch back. It could actually be because when we do our render copy there, the texture has a hole in it, basically. So, yeah. So I guess, you know, technically our original clear wants an alpha of 1, and our subsequent clear wants an alpha of not 1. So really, let's take a look here. Inside render.cpp, where we call clear rectangle, you know, technically, I guess what we do want to do is something like this. Actually, I got a better idea. I think what we actually want to do is say, hey, when we display a bitmap via OpenGL, we just want to make sure that blending is not on, right? So like we want GL disable, GL blend, so, and then we can re-enable it after. I think that's actually the more correct thing, because we shouldn't be blending that bitmap anyway, and that's what was actually happening, I believe, there. Yeah. So now we're good to go. All right. So let's see what happens as we hop up ye old stairs. Nicely blended. So that's all good. And so I think everything is fine now with our clearing and all that stuff. So I think now our primary thing that we have to fix is that we clearly have a bug in the actual texture fill for things that are sheared, right? So that's got to get fixed. And the other thing that looked like a problem was the sorting groups were looking odd. Looks like they're okay here. So I guess it's just when we went up the stairs. And of course we haven't finished this renderer yet. We haven't added the render targets to it. So I suppose we have to go do that at some point before we can start debugging this by, going up the stairs and seeing if that's where we were having trouble with it. But I just wanted to double check what was going on there. All right, so we'll tackle that bug first, which is inside our draw rectangle quickly. Let's see what we've got. Besides being out of stuff to drink. Let's see. We have a bug in our texel lookup where we're not properly computing the texel or fill values. This does seem true. We're taking a look at a normalized. So these are just normalized versions of our axes. So they're versions that point in the same direction as the axes point, but without having the length, right? And so seems totally reasonable, not really a problem. And the fill region is computed from the original axes, and that looks like exactly what I would have expected. So let's take a look in here and see where we're actually using these. So when we do our U and V lookups, what we're doing there is we're multiplying the axis normal X by whatever I assume that's where the pixel, wherever we are on Y. So we're basically producing measurements along the normalized axes. Now, why we're producing measurements along the normalized axes, I'm not 100% sure. Because it seems like what you would want to be doing is producing them instead along the inverse scaled. So those actually aren't normalized per se. That's the y-axis length over the x-axis length. So it's actually like a very strange, that's a very strange thing to be computing, right? We're baking in a normalization of the x, but then a scale by the y, by however long the y is. And then similarly, the other way around, we're doing a scale in the opposite direction. So we're basically exchanging the lengths of our axes. We're making the x-axis be as long as the y-axis, and the y-axis as long as the x-axis is what we're actually accomplishing here. Why we wanted to do that, I don't know. This is where going back and watching the video would probably help. So it'd be like, oh, that's why I wanted to do that. And so in here where I'm saying how I'm computing the values, it looks like I'm taking where the pixel is in y relative to the origin, and then I'm sort of finding out where it is on those two sort of weird axes. I assume those were directly the axes. Yeah, they are. So I'm measuring it along those, and I'm saying that the u and v values are, are mappings into those sort of odd spaces. That just doesn't seem, that seems wrong to me. And we know that it is wrong, I guess, because we're looking at it being wrong. But I'm also not sure why what were we trying to do with that? Do we remember? Like, that doesn't really make a whole lot of sense. That doesn't really make a whole lot of sense to me at all. So what I would have expected to see, right, is I would have expected to see something where I was mapping into the U space by multiplying, by dot producting with dot producting with an axis that was designed to give me back a number from 0 to 1 along myself. Which would have been, yeah, I don't get it. So what I would have expected this to be here is, like, instead of the x-axis being like y-axis length over x-axis length, I would have expected it to be like, that being a normalized x-axis, and then because I have a normalized x-axis, but I know that the thing is going to run further than that, what I actually want to do is divide by it again, right? So that is, I think, what I would have expected to see. And I wish I knew why I didn't see that, right? I would have expected to see something like that. And you can see right here I did in x-axis length squared. This right here is exactly what I was expecting. Oh. Whoa, that's freaky. Huh. Okay. All right, I'm gonna get rid of this stuff. I'm just gonna delete this. Okay, thank God. That makes a lot more sense. So inv-axis length squared is, there we go. So that, it looks like I just kind of psyched myself out there by having some weird old vestigial code that is not what I wanted at all. So yeah, inv x-axis length squared times x-axis for this guy, that actually makes a lot more sense to me. So that's all good. There we go. All right. So at least now I'm not looking at something that looked like it was kind of out in left field. So now let's try to look at, like, obviously that was not correct. So let's try to figure out what went wrong here in our reasoning, because it looks pretty straightforward. Like, it looks like computing that dot product is pretty straightforward. What I suspect is that I must have I haven't thought through whether I can take the dot product when the two things get skew like that. It may be that I can't, and I have to be a little bit more. I have to take some extra terms into account. It looks like we're almost out of time, so I won't work that out on the whiteboard today, but that's what we'll do tomorrow. And basically, just to point out what I'm talking about. So when you have two orthogonal bases, right, and I'm talking about a point in here, I can measure it here and I can measure it here, and that's how I was getting basically the u and v coordinates. I was saying, here's a point inside, this box, and I want to measure these two. Now, if these are both unit vectors, then it's just the dot product, right, of the point, and it's fine. But we know that they're not, right? They actually have some length, so they're actually some, however long they are, right? This is the length of the y-axis that we pass in. This is the length of the x-axis that we pass in. And so when we dot product on them, we're going to get, if this is my px here, we're going to get the dot product of these two things. If I didn't modify the axis, right, we know it's equal to sort of the length of each of these vectors, length of px times length of x, right? times cosine of the angle between them. These two values in here, I like this one, right? I want to know how far along I am on this thing for sure. But I don't like this one, and the reason for that is because now, however long this is, I want my u and v values to be in the range of 0 to 1, right? But now I'm getting this thing in here that's actually going to multiply as you go further out. It's going to make it worse and worse, right? So that's why I was doing the 1 over the length of x squared, is because I was using this dot product to bake in the normalization from 0 to 1, right? To counteract this and then also divide by x, so I would end up with this, which is what I actually wanted, right? I was trying to end up with that. Now that works just fine when things are orthogonal, but the question is when I start passing in things that aren't. So suppose I've got something that looks like this, right? Well, now any motion in x or y is actually going to affect my location potentially on both of these axes, right? Because this is my projection, because this is my projection here, and this is my projection here. And so when I move in y, I'm actually moving in both u and v space, and when I move here, I'm moving in both u and v space. And that's correct, meaning that is what should be happening. But we don't know if we did the math correctly to actually get the correct thing to happen, right? We may have to create different basis vectors or a different math operation to actually do that mapping. So that's what we'll have to do tomorrow. Let's go ahead and go to the Q&A. Chris Platt, Handmade here. Earlier when the pink color showed up, that was the color you used long ago when you were setting up the OpenGL render. Yeah, but I was confused as to why we were getting it, right? I know that's, that's the pink that's like, hey, there's a problem, but I didn't know why. So let me just briefly explain why it was happening. So the reason it was happening is we have an OpenGL like back buffer, right? And when we do the software renderer, we were previously making a completely solid bitmap because our clear set the alpha to 1, right? So everywhere in here, the alpha value was 1. There were no holes in it. So when we then drew it using OpenGL to the OpenGL back buffer, it didn't leave any space. But now what we're doing is when we clear that, where we were clearing that back buffer, I was clearing the alpha to 0, which meant that if this is what you actually filled in when you drew the back buffer, this was actually now an alpha hole where alpha was 0. So when it then went to draw to the screen, whatever was in the back buffer to begin with, whatever was there, a hole would be left when this got blitted onto it, right? Allowing stuff to show through that was not the clear color. So that was just because when we did that blit, that's happening. Now, the the solution to that was I was like, well, I don't want the blit to actually take that into account. So what I did is I turned off blending. So now there's no more blending on the blit, which means that alpha holes don't show through, right? It's not using the alpha to do anything, and that's sort of a better situation, I suppose. This Isaac, are the PYNX and V calculations correct? I don't know. We're going to have to look at them tomorrow and see. They might be wrong. Well, we know they're wrong. We just don't know how they're wrong. I mean, they're obviously wrong because they're picking the wrong texture coordinates. As far as the vectors go for movement, can you just add U and V to get the new movement? No. We have to have U and V calculated separately because they look up into a texture map. Brian E. Wag, could normal maps be render targets here with appropriate enums branching to blend and light, or do they still belong outside the current render targets array? Well, normal maps would be part of the sprite. They wouldn't really be render targets. They would just be, they'd be like an art asset, right? That gets loaded in along with the sprite, like whatever its normal map is. So I don't think it would really implicate render targets unless you're talking about something else. Realista1, do you think you could transform this game into a network game that multiple players can have different kinds of character assets? Yes, obviously we can. I mean, you can transform any game into that. And if yes, will you consider doing it? No, networking is not going to be covered on Handmade Hero. I kind of said that at the outset, and that's just something I'm not going to be doing. This Isaac, as in, it looks like there might be an XY swap in those two variables. You think? I feel like an XY swap, a straight up XY swap, is unlikely, because if there was, our characters would be coming out rotated 90 degrees, well, you know, flipped, like that. So it can't be a straight up, it has to be a little bit more complicated than that, right? Brian Wag, I'm comparing it to deferred rendering, which I'm next one. So we're not a deferred render path. So if you're doing deferred rendering, then you have to have a render target for basically every possible property that you need to have for your final lighting equation. So you might need a specular power place in the render target, a normal map. You might have to have a material index, all these sorts of things, right? So yeah, deferred rendering path is very different, and you have a lot more render target space depending on how much you can afford, right? And you tend to pack a bunch of stuff into those render targets, and then you do a final pass on the screen where you look up into the render target to get all that stuff. Realista1, you should do networking. You could charge for extra items or levels, thus making a reliable stream of money. No, I don't think so. The Isaac, I mean, you used an X variable where you meant a Y variable. Yeah, I mean, we'll find out tomorrow. Obviously, that would be nice if it's that simple, but I suspect it's more about the underlying concept of doing the dot products that way is probably not right once you start to skew. That would be my assumption, but I mean, you can see here it's pretty basic, right? You've got the pixel PY value, and you compute the dot product of basically the component of the dot product of the X and the Y with the PY, right? And then in the next phase, you compute the component of the dot product that's the X, you know what I mean? And you add it to the one that you had before to get a complete dot product. So I don't think there's a lot of room for error in that. I mean, that looks like it's doing the math op correctly. So I will find out, but I feel like it's the math is conceptually wrong there for skew, if that makes sense. I think that so all right. I guess I'll just give a brief explanation of why my intuition says that that's the case. So if I have, essentially what we're talking about here is we're talking about when you have two basis vectors like this, right? And here's my y basis vector and here's my x basis vector, right? And I want to know what the UV coordinates for this thing are, something that expresses that in as if this were a texture, that was warped kind of on here. Then essentially what I'm trying to do is I'm trying to invert this matrix problem in some sense, right? What I'm trying to do is I'm saying, well, I had, something like this. Let's say that. And now I have this, right? And what I want to know is I want to know where this thing was in the original space, right? And so these two vectors here, they form my A matrix, essentially, right? That's what they're effectively doing. And I basically have this problem, right? And so what I need to do is I need to do that to solve for the original point. And we're not actually doing that inversion. We're just transposing, basically, right? And so I think the problem is we actually need to invert that matrix for real. The matrix that is, the x-axis and the y-axis sort of a thing. I guess I should say that. Right. And I think basically what we're doing now is this, which is wrong. But again, only when you're skew, right? It's wrong only if you skew, because otherwise the matrix is orthogonal, and therefore you can do this, because for an orthogonal matrix, and I don't mean orthonormal matrix, I mean orthogonal. 1 over the length of the vectors, like if we normalize those vectors, 1 over the square of the vector lengths, when we produce the transpose matrix, then we'll do the right thing as long as all you're doing is scaling. And I know this is confusing because we haven't covered matrix math, but I'll go over it tomorrow when we actually have to solve this bug, because I'm pretty sure that this is the problem. So I think I need to go do a better math for that. What is the Blackboard software you're using? It's called Milton. Looks like someone gave you the that link already. So Nub3Sock asked if you would consider local multiplayer. We already support local multiplayer. I guess maybe you weren't here since the earlier days of the stream, but you can join as many people as you want on the same machine right now. Right now, like if you just plug in an Xbox controller and push the start button, a second hero will appear. I don't think the eventual game will not support local multiplayer because the game design doesn't support local multiplayer. It's not a multiplayer game. But the engine handles it just fine. Miblo asks, speaking of normal maps, could we have used those to help sort the sprites? I know they don't give you 3D data, but is there anything in there that we could leverage? I mean, yeah, maybe. I mean, a normal map does sort of have some correlation to depth. It's not exactly right, but, it's not nothing. So, I guess I'm not sure how to answer that exactly. I would suspect that it's probably not worth trying to do it, at least not for this game, maybe for other games. But even in other games, I suspect that it's still just not really the information you need. You know, you really more need a depth map, and you also need a scale value that lets you know how that depth map corresponds to the actual world. But yeah, it's an interesting idea. I just don't know that it can really be put into practice that much. Because basically, a normal map is a you know, you could think of it almost as like a derivative, the derivative of a depth map. But what you actually need is the depth map, and you don't have a way to integrate the normal map back up to a depth map because you don't know how much. You know, you don't really know anything about where the surface started or anything like that. But you could try. You know, you could integrate a normal map up and see. I don't know. It sounds like it would be a lot of work for not a lot of payoff, but that doesn't mean it wouldn't work. You know, you just have to write a thing that basically does an integration, integrates the normal map, and goes from there. So. All right. I'm going to wrap it up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code. Yeah. So you can play around and experiment with it. We also have a forum site where you can go to ask questions, a Patreon page you can go to if you want to support our video series, a schedule bot that tells you when the series is going to be live in case you want to catch it when it's on, and we also have a episode guide that you can go to catch up on old episodes. That's about it for today. I'll be back for the last stream of the week tomorrow at 8 p.m. Pacific Daylight Time, I believe. Until then, everyone have fun programming, and I'll see you on the internet. Take it easy, everyone.